Hello friends, welcome to FreeCAD tutorial, and in this tutorial we will convert this orthographic drawing into the 3D model. And as you can see that I have already converted it and it is matching with the isometric view of the drawing. And in this tutorial we will not only create this 3D model with the help of this orthographic view, but also we will create the drawing, how we can create a detailing of any parts. And if you see in this drawing, if we apply GD&T and tolerances, so we can release this drawing for the production. But this tutorial is designed for the user who wants to learn modeling as well as detailing in a FreeCAD. So I will close this file and create a new file, and we will start creating model from this view, and then we will create a drawing. So let's start. You can also visit my website mechnexus.com, where I write articles and tutorials on FreeCAD. You can download my tutorial source file from here, tutorial source file page, and you can also support me by buying a cup of coffee on ko-fi.com. Your small support will help these channels to grow, and it will motivate me to create more awesome content on FreeCAD. I thanks to all my supporter, those who have supported me by buying a cup of coffee. So keep supporting, and it will help me to grow this channel, and it will motivate me to create more awesome and useful tutorials on FreeCAD. So let's come back to our tutorial. So here I have created a new file, and I will switch to the part design workbench, and I will create my body and then select option to create a sketch, and we will select this front plane. Now if we zoom our drawing, so we can see that inner radius is of a 50 and outer is a 60. So we will simply create a 3-point arc and make it a coincidence, and we will create one more 3-point arc, and we will select this and make it coincidence. And now we will close our profile, and I will select this and add a horizontal relation. Now we will provide the dimension, so we will select radius. Inner one is of a 50 and outer one is of 60. Now I will move these dimensions. Our sketch is fully constrained. We will come out of it and we will create an extrusion of 80 mm, which we can see here. So select the sketch, click on extrude, and we will keep it symmetric to the plane and provide the dimension 80 mm. Click on OK. Now if you see in a side view, there is a distance given 12 mm, which means that we will create a datum plane at a distance of 12 mm from this face. So click on the datum plane, and in the Z direction I will provide the 12 mm, and I wanted to reverse this direction, so I will provide here a negative symbol. Now I will click on OK. Now we will create our sketch on this datum plane, so we will select it and click on the sketch, and from here we will switch to the wireframe view, and let's hide this datum plane. So first thing which we will do is to project that outer radius. Click on project, and we will create a 3-point arc, And now we will rotate our model, select this and this arc and made it equal, and we will select this and this point arc center and click on the coincidence. Now we will create this profile. So for this, first we will select a line tool and draw the horizontal line, and here we will create a 3-point arc and select this and add a coincidence relation, and this is of a diameter 40, which means that radius will be 20. So select a radius and give it a 20 mm. Now we wanted to fix these center points. So if you see here, it is given the 110. So I will select a horizontal dimension, select this and give it a 110. Now there is a arc of R25, so we will select a 3-point arc and create an arc, and this is of R25, so we will select a radius and give it a 25, and we will move its center, or there is a vertical line which will be tangent to this arc. So first I will create a vertical line and add a tangency, and now if you see here, so we can see here the 10 mm, 20 mm, 10 mm means 40 mm. So we will draw a horizontal line and select horizontal dimension and provide the 40 mm, and we will create one more vertical line here. So select line tool, draw the vertical line, and here is a given radius R50. So we will again select a 3-point arc and create an arc, and let's add a tangency relation here, and here also we will add a tangent. Now we will fix this vertical height from this our origin. So select a smart dimension, and vertical height is of 150, which we can see here from this edge to this axis. Now we will constrain this, which is of radius 50, click on OK, and now here if you see 110, and this radius is unconstrained, so we will select this and made it equal, and let's try to move it. What is unconstrained? So now our sketch is still unconstrained because we have not assigned relation between this and this. So we will select this and add a vertical relation. So if you see here, this got fully constrained, but this arc is not. So if we move it, and here we can see that this line having no any relation, so we will add a horizontal relation, and we can see that this arc is unconstrained because we have not added tangency here. So let's add a tangency. So this is fully constrained, and now here is unconstrained, so we will select this point and this point and coincident. So our sketch is fully constrained. Now we will come out of the sketch and we will switch to the flat lines. And we will select our sketch, and if we see in a top view, so this is the 56 of extrusion length. So click on the plat, reverse, give it a 56, click on OK, and now we will switch to the front view. And if we see our isometric view, so there is a circular profile, and if we see in a top view or in a side view, it is a symmetric with our mid plane. So we will switch to the isometric view on our origin plane and select this exit plane and click on sketch, and we will off this origin plane. And now all we have to do is project this arc. Click on the project geometry, and we will create a circle equal to our projection. And now I will come out of the sketch, and it is of 70 mm. So I will select the sketch, click on the pad. Here I will give the 70 mm and I will select symmetric to the plane, click on OK. Now switch to the isometric view. Now if we see our isometric view, so here is a cut, and we can also see in this front view. So we will create this cut. We will select the face and click on the sketch, and for better sketching we will switch to the wireframe view, and we will project this vertical and this horizontal edges. Click on project geometry, and now I will create a rectangle, and I will delete this one. And if you see here, the width is 20 mm is given, so I will give it a 20 and select this and this. I will give it a 10 mm, and from here it is a 10 mm. It is over defining, so I will close it. Now I will select this point and this construction one and make it coincidence, and here is a 10 mm, which means that if this radius is 50, then it will be the 60. So I will select a 3-point arc, and I will select this two and add a tangency, and here is a 10 mm is given, which means that this radius is 60, so this will be the 70. So I will select a 3-point arc, create one arc here, and let's add a tangency here first, and move this point, and select a 3-point arc, select this and this, and select this and this, and add a tangent. And now I will move this, and here I will extend this line and connect these 2 points with the help of an arc. So select this and this, add a tangency, select this and this, and add a tangency. And now here we will project this outer diameter. So click on the project geometry, and now select this point and this point and add a coincidence. and select smart dimension, and it should be the 70. This is the R10. Now select this and add equal constraint, and here we will project this arc, and we will add this and this as a coincidence relation. So our profile is fully constrained. We will come out of the sketch, and now I will switch to the flat lines, select the sketch, and click on extrude cut, and say it through all. So here, switching from flat lines to wireframe, here is a keyboard shortcut is given. You can also use this keyboard shortcut. Now we will create this hole here. So select the face and click on the sketch, and its detail is, it is of a diameter 20. So I will click on project geometry, project the diameter, click on the circle and select smart dimension, and give it a diameter 20. Click on close, and we will go to the hole tools, and here I define my drill size of 20, and from here I will say it through all, say OK. Now we will move to the next feature. The next feature is to create a datum plane at a symmetric. So first we will create a cut. So we will remove the material at this portion, and then we will add the material. So I will simply select this face and click on the datum plane, and here in offset I will give the 10 mm as my offset distance. So you can see that plane is inserted. Click on OK. Now I will select this datum plane and click on the sketch, rotate my model, and from here I will switch to the wireframe, and I will project this edge, and here if we see in a side view, so this is of a R28. So we will create a circle, and we will select the diameter, (28) multiplied by 2, which is 56, and now I will select this and this and add a coincidence. Now select this point and rotate it, and select this construction one and add a coincidence. Close it, hide the datum plane, switch to the flat lines, select the sketch, click on extrude cut, select symmetric to the plane, say through all, say OK. Now we will again select the datum plane. Now we have created the cut. Now we will create this circular profile on the same datum plane. So we will select the sketch, now click on the project geometry, and now we will rotate our model. We will create an equal circle as per our construction. So select the circle and click on close. Now I will hide my datum plane, select the sketch, click on extrude, and here is a extrusion is of a 60 mm. So we will select symmetric to the plane, 60 mm, and click on OK. Now we will create a next feature, which is this one. So we will on our datum plane and use the same datum plane to create our sketch. Now we will switch to the isometric view, And first we will project this diameter. Click on the project and project this diameter. Switch to the right view, and from here switch to the wireframe, and here we will see the details. So here is a R20 is given, so we will simply create a 3-point arc, and we will select this and made it equal first. And now here it is 35, so I will select the symmetricity constraint, select this point and this axis, and now I will select the polyline tool and close my profile, and make this horizontal, and this is the 40 and this is R15, so 40 plus 15 is of a 55. So from center to this top point is of 55, and this horizontal one is of a 35, so give it a 35 and add it a vertical relation. So our sketch is fully constrained. We will hide this datum plane and switch to the flat lines, and now we will create our extrusion of our sketch is fully constrained, and here we can see the radius is a R15, so we will select it and click on extrude, set it symmetric to the plane, and we will give it a 30 mm. Click on OK. Now we will provide the fillet of R15, so I will select these two edges and provide the fillet of 14.99. Now we will create this hole of diameter 15, so select the face and click on the sketch, click on the project geometry and create a circle and select diameter, give it a 15 mm, click on close. Now go to the hole wizard and give it a 15 mm, and from here say true all, say OK. Now let's move to the next feature, which is to create this cut, which we can see here in isometric view. So we will select this face and click on the sketch. We will rotate our model to the right orientation, and now first thing we will do is to project this outer diameter, and from here we will switch to the wireframe, and I will create a circle. Now I will create a rectangle, and I will use the trim tool, select the trim it, and this is of a diameter 15. If you see in a side view, sorry, it is a diameter of R10, so we will do the diameter of 20 mm, and as we wanted to remove the material, so this height is not a constraint for us, so we will give, let's give the 60 mm, so that this should become outside of the body, and I will make this and this symmetric, So here I will use the symmetricity constraint, select this point and this axis, and I will select the horizontal dimension. And if you see in a side view, here is a 5 mm is given. Click on OK. Now click on close. We will switch to the flat lines and select the sketch, click on extrude cut, and from here I will say it through all. Now if you see our model, so we have made this feature, this one and this one. Now we will create here this face. So this is on a mid plane, so we will on our mid plane, and we will select this exit plane and click on the sketch. Now I will off my origin plane and I will project this outer radius. Click on project geometry and let's switch to the wireframe, and here height is given is of a 20 mm. So we will create a 3-point arc, and I will select this and made it equal, and I will select a polyline tool and draw the approximate profile. Now select line tool. Now the height is given is 20, so we will select a smart dimension and provide the 20 mm, and this is the horizontal. And if you see here, so this is given 50, so which will be used in extrusion, and from the center it is 80 plus 20, 100. So we will select a smart dimension, select this point and add a 100 mm. Now I will close it, switch to the flat lines, and now we will extrude it to the distance of a 50. Select the sketch, click on extrude, and we will give it a 50 mm, and never forget to make it symmetric to the plane, and click on OK. Now we will create this hole, so we will select this top face and click on the sketch, rotate our model to the right orientation, and we will click on the circle and create a circle. So position of this hole is the 80, so we will switch to the wireframe so that we can get the origin point. Select this and provide the 80 mm, and this whole dia is of 16, so give the 16, click on OK. Now select the sketch, go to the hole wizard and drill size of 16, and simply say true all, say OK. Now we will provide the fillet of R10 to these two edges, which we can see here in isometric view. Select it and provide the 10 mm, click on OK. Now we will switch our model to the isometric view. So you can see that we have successfully converted this orthographic drawing into the 3D models. Now we will apply the color which will match to the isometric view. So select the last feature, go to the appearances and go to the custom appearances, and let's give the approximate color. So this is how we have a successfully created a model and also apply the color. Now we will also create a drawing of it with respect to the front, top and side view. So I will close this file by saving it. Let's I will give it a revision R1. Now now we will create a 2D drawing of it. So I will switch to the text draw workbench, and in a text draw workbench first I will insert my template. Click on the template, and here I will use A3 landscape minimal, and I will go to the my model tab. So this is our base view. So select the base feature and click on insert view. Now here we will set the scale type page, and here I want right side of view. So here it is a first angle of projection, but our drawing is at a third angle of projection because we are seeing this circular profile line visible, and this feature is in a hidden. So this is a third angle of projection. So I will switch here to the third angle, and now I will place my top view. So once the views are the place, we will set to OK, and now we will change our scale. So our scale is of the page type. So here let's give 0.6 scale, and click on rebuild. If view is not updating, then save it. If it is still not updating, then expand it, go to the projection view and say OK again. So it will recalculate it. Now I will move my side view and my front view. Now once the view position is OK, I will lock the view position. I will lock this side view, and I will also lock this top view. And now we will insert the dimensions. So let's start with the front view. So here we have to on the hidden line if you wanted to give these dimensions. So select the base view and go to the options here. Here is a hard hidden is a false, set it true. So you can see that now hidden line is on. So first thing which we will do is to enter the center line. Select this and this and add a center line. And now let's give the dimension. Select these center points and this, and provide the horizontal dimension of 80. Now from this to this cut point, select and provide the horizontal dimension of 20 mm, and select this point and this point and add a vertical dimension of 20 mm, and this radius is of R50 and outer one is a 60. So select it and go here and select the radius dimension R50 and select the outer one and give it a R60. And now here is a 10 mm is given, so this will become the R70. So I will select this one and go here and select the radius and move it. Now from this center to this center, give the horizontal dimension which is of a 110. Let's move it little bit down. Now we will provide this diameter 20 and 40. So we will select the inner diameter, go to the diameter, this is of a 20, select this and provide the diameter 40, and this is of R25, so select it and provide R25. And now provide these two radius R10, so select this and provide it R10 here, and select this and provide it R10, move it. Now we will provide this 150 dimension. So for this we have to insert a center line, so we will select this and add a center line between two lines, click on OK. And now we will select this chord point and this chord point. I can also select a line, but this chord point is on this axis, so I will select a vertical dimension and provide the dimension of 150. Now from this axis to this one is a 105, so I will select this chord point and this axis and select the horizontal dimension. So here is it is coming 105, but here is coming 125. So if you see here 2080 and 110, it is a matching, and this is a fix, and here it is a R50. So let's check it, select it, first select the radius, and so this is the R50, but here it is given 105, so we will go in our model and we will correct it. So this is the pad, and we will select the sketch. So here it is a 80 mm, and from here it is given 105. So what we will do, we will create a line and make it a construction, and we will select a horizontal dimension, select this and provide it 80 mm, and now if we see here it is a 110 and it having the vertical relation here. So what we will do, we will delete this vertical relation and now see Now from this to this we will provide 105. So select smart dimension, select this and provide it 105. So it is a calculating. So this is how we have found the mistakes in our modeling, and we have corrected it. Now I will come out of the sketch and I will on the one feature one by one to check it if there is any failure in the model. Okay, now I will hide this datum plane and I will save it and go to my drawing view. So here some of the things got disturbed. Now we will fix the dimension which got disturbed due to the model changes. So I will delete it, and here I will again insert the center lines and click on OK, and here I will also delete this dimension, delete this and delete this. And now I will move my dimensions to the right positions, and now we will select this axis and this chord point. Now our required dimension is a 105. So now it is perfect. So you can see that FreeCAD is a parametric. Once we have modified the models, our drawing is also changed. Now I will select this and provide the horizontal dimension of 80 mm, and I will select this axis and this chord point and provide the horizontal dimension of 20 mm. And now let's provide the dimensions here. This 10, 10, 20 and 10. So we will select this and this, provide the horizontal dimension of 10 mm, select this and this, select the horizontal dimension of 10 mm, select this and this, provide the horizontal dimension of 20 mm, and select this and this, provide the horizontal dimension of 10 mm. Now we will provide this dimension. So we will select this chord point and this chord point and provide the horizontal dimension of 60. Select this and provide the radius of R15. Let's move it. So here we have given the radius of 14.99, because if I give the round figure it fails. So here I will go to the precision option and decrease the decimal places, and we will select this diameter and add diameter dimensions which is of 15 mm, and select this chord point and this center points and add a horizontal dimension of 30 mm, and here I will decrease the precision. Now here I will unlock my top view and move it little bit upper side, and again I lock it. So if you see our front view, we have given all the dimensions, and now let's move to the side view. Now if you see in a side view, there are the two dimensions, 12 mm, 12 mm. Now I will select these two chord points and select the horizontal dimension of a 12 mm. Select this and this at a 12 mm, and now here I will on the hidden line, so I will select this view, and here hard hidden is a false, set it true, and now you can see that hidden line is on. And now I will insert a center line, but this chord point as a center, so I will select this and this center and this chord point, and add a vertical dimension of 40, and here I will decrease the decimal place to make it round of 40, and here it is of R28, so I will select the radius and give it a R28, and now this cut is of a 5 mm, so I will select this and this, and add a horizontal dimension of a 5 mm and move it, and select this and add a horizontal dimension of 35. So you can see that we have given all the dimension of a side view, and let's move to the top view. Now here we will also on the hidden view, so hard hidden is a false, set it true, so that we get a hidden lines. Select this point, and add a vertical dimension of 70, and this is of a 5 mm. Select this and add a vertical dimension of a 5 mm. Select this line and add a vertical dimension of 56, and select this and add a vertical dimension of 35. Now we will provide this 60 mm dimension. How much it is, let's zoom it. So this is a 80, and we will select these two chord points and add a vertical dimension of 80 mm. Select this diameter, give the diameter dimension of 16, and this is of R10, give it R10, and this width is of 50 mm, so I will select if you are facing problem in a selection, then zoom it and select the chord point and give it a dimension 50. So if you see, we have given all the dimension in a top view, front view and side view. Now we will off the frame, and we will now insert the center marks. So I will select this radius and set the center marks. Select this and add a center marks, and select this and add a center marks, and now in a side view we will insert a center mark. Select this and add a center marks, and here we will select this edge and this edge and add a center line. Similarly here we will select this and this edge because these are the longest edge, and we will add a center line. Click on OK. Now we will also add one center line here. Select this and this. Click on OK. And we can do few things like this 5 mm dimension. We can add a equal symbol so that it is a symmetric with the center line. We can do the same thing with the 70 mm dimension. Add the equal symbol so that it is a symmetric with the center line, but we have not drawn the center line, so we will select this edge and this edge and we will add a center line. Click on OK. Similarly, we will select this edge and this edge and add a center line. Click on OK. Similarly, we will select this and add a center mark, and we can also add a center line so that our drawings looks good. Okay. Now these two dimension we can also add symmetricity so that these are the symmetric with the center line, and this 35 as well. Even though these details are not given here, that is my understanding. And this 5 mm we can also add the equal symbol, and this 50 mm as well. Now let's move it, and now we have successfully given the dimension with respect to the orthographic view. And now we will insert this isometric view. So we will go to the model tab, we will switch to the fit all and set our model to the isometric, and we have selected our body here. Make sure your body should be active and click on here insert active view, and from here click on the crop image so that we get options to customize the border of our this view. Click on OK, and now switch to the drawing view. So you can see that this isometric view is placed, but we have to on the frame if we wanted to move our active view. So here we can see that the border is larger than our view, so we will go to the its property. So here let's make it a 90 by 90, and let's increase the scale. Let's make it a 1.4, and now we will make it a 110 and 110. Let's see, little more we want to increase in height, let's say 120. So you can see that now it is a perfectly placed. Now we will off the border, and I will move my drawing to the correct position. So this is how we have successfully modeled this part, and we have also created the 2D drawing. You can apply the GD&T to this part and other technical details. You can on the frame, and you can edit the title block field like it is a FreeCAD modeling and drafting. Let's I edit the title modeling and drafting in FreeCAD. Click on OK. This is not an assembly drawing, this is part drawing, so I will make it part, and here I enter my name, created by me and approved by me. So let's see the OK. So this is how you modify the title fields. So this is all about this tutorial, how to create a model and also create a drawing in FreeCAD. This is modeling and drafting tutorial in FreeCAD. Thank you for watching and thank you for your valuable time.